In this video, we're going to talk about how we can write exponential functions and also power function given the coordinates of a couple points of their graph. So in example 1, we're going to write the exponential function that's of the form y equals a times b to the x, whose graph goes through 1, 8, and 2, 32. The whole idea, guys, is we really need to find out what is the value of a, right, and what is the value of b. We have to find those two things and we will have the graph. Well, or the equation. So what we're going to need to do is utilize the fact that we know when we plug in x as 1, we'll get an output of 8. So we can write an equation giving that coordinate, and then we'll also be able to write a separate equation given the fact that when we plug in x as 2, we'll get an output of 32. So let's use this first coordinate to set up an equation. If we put in 8 for y, we should get 8 equals a times b to the power 1 for x, which simplifies to 8 equals just a times b. If we utilize this coordinate, we can say, alright, y will be 32, and that'll be equal to a times b to the power 2. Now we have two equations, this guy and we have this guy, and we have two unknowns, so we should be able to solve this. Now there's a few ways of going about this. What I would do is I would solve for a in this first equation, and then I'm going to substitute that expression in for a in the second equation. So let's go ahead and solve for a in the first equation by simply dividing both sides by b. And if we do that, we'll get a equals 8 divided by b. And now what I can do is substitute that expression 8 over b in for a in the other expression and try to solve for b. So 8 over b is going to be equal to 32, and we're multiplying that by b squared. Now of course we can simplify. B goes into b squared once, so we'd be left with just the b in the top, or in other words 32 equals 8 times just the b. So we can solve for b just by dividing by 8, and we would get 4 is b. Well, now that we have 4 for b, we should be able to figure out a using that equation to the left that we already have solved for a. So if I have 8 over b equals a, but I know that b equals 4, I can put in 4 for b, and I can figure out that a is really 2. So I have my a, I have my b. I should be able to rewrite this equation now as the following. Y equals, we said the a value was 2, so it'll be 2 times the b value, which is 4, to the power x. Now please don't make the mistake of thinking you can multiply 2 and 4 and write like y equals 8 to the x, because you really need to raise 4 to the x first, right, and then multiply by 2. So do not make that classic mistake of doing that. So you're really done. That's your exponential function. I know it says you have a checkpoint, but I'd like you to skip that checkpoint now and look at the next example with me. Example 3. I know it should say example 2, but we are just jumping to example 3. We're going to write a power function, which is a little bit different. It's not an exponential function. Notice how x is not the exponent, right? X is the base of the exponent. Oops. Sorry about that. Let's go back. X is the base of the exponent, and it's not the power. So this is just a power function. We're going to do the same thing. Ultimately, we need to find what a and b is, and we're going to use the two different coordinates to substitute in for x and y to set up two equations so that we can solve for a and b. Let's set up an equation using 3 and 4. Now remember, 3 is for x and 4 is for y, so I can rewrite that equation as 4 equals a times 3 to the power b, and for this equation I can say 7 equals a times 6 for x to the power b. So all I do is substitute in the value for x and y. Now it's going to be hard to solve either one of these equations for b, but it's not so bad to solve for a. So I'm going to divide both sides by 3 to the power b for this equation, and that will let me solve for a. So I'm going to have a is the fraction 4 over 3 to the b power. Now what I'm going to do is I'm going to substitute 4 divided by 3 to the b in for a in that other equation. So I'm going to get 7 equals, it was what, 4 over 3 to the b power times 6 to the b power. Well, this is where things kind of get a little bit tricky. Remember, when you multiply fractions, you can multiply top to top, bottom to bottom. So if I do that, if I multiply top to top, I'm going to have 4 times 6 to the b power over bottom times bottom is just going to be 3 to the b. Now, because these guys are both being raised to the b power, I can do the following. I can rewrite that as 7 equals 4, and then write the quotient of 6 over 3 all to the b, because after all, when I have a quotient to a power, I would just distribute that power to the top and the bottom, and I would then get that previous step. So far, if I simplify that, I'm going to have 7 equals 4 times 2 to the b, and now I'm in the point where I have an exponential equation that I need to solve. And what I could do from here is divide both sides by 4, and I have 7 over 4 equals 2 to the b power. And now what I'm going to do is log both sides. I'm going to take the log of this side, and I'm going to rewrite this and take the log of 2 to the b, because what that's going to allow me to do, of course, is drop down the exponent b in front. So I'm going to have the log of 7/4 equals b times the log of 2. My last step is to divide by the log of 2. Log of 2. So I've just figured out that b, it's not very pretty, I admit, it's the log of 7/4 over the log of 2. Now, what we might want to use is right now is a calculator, because the log of 7/4 over the log of 2, it's not a very pretty expression. We're just going to need to round this. But 7/4 is the same as 1.75, so I can really do the log of 1.75. Now, when I use my calculator, I'm going to make sure when I type this in, I close the parentheses, then I'm going to hit the division sign and divide it by the log of 2. So try this with me, please, and make sure you're doing it right. I'm going to type in the log of 1.75, close parentheses, and divide by the log of 2. And if you do that, you should get approximately, let's go 3 decimal places, 0.807. So I have 0.807 for b, approximately, right? That's not the exact value, that's about right. Now, to get the a value, the probably best place to go back to is right here, back to that equation, and I can substitute that 0.807 in for b to get a. So let's try that, but I'm going to go ahead and do that. Oops, let's get back to here. I'm going to do that over here and rewrite 4 over 3 to the 0.807 equals a. So if you type this in your calculator, just make sure, when you type in 4 and you hit the division button, you want to make sure that the 0.807 is in your parentheses. So hit 4 divided by 3 raised to the power 0.807. And if you do that correctly, you should get a is approximately 1.648. So at the end of the day, if you put all of this together, we have just figured out a power function where the a value, if I substitute in the a value we found, we have 1.648 times x to that power of 0.807. 0.807. So not a very easy problem. Actually, you would think that doing a power function would be easier than the exponential, But it's kind of tricky with this whole log business down here, and you know, realizing the quotient of a power, or excuse me, the power of a quotient property that we had to use right in here. What I would like you to try to do right now is you have a self-quiz. If I can get to the last slide here, where is it at? Here we go. We have a self-quiz. You have an exponential function to do first, and then you have the power function. Remember, this one will be like example 1, and this one will be like example 3, which is really the second example we did, right? Good luck, and we'll talk about this when you guys get back to class. Thanks for watching.